Hello and welcome to Honors Function. In this lecture, we'll be looking at some example of concrete situation that involves arithmetic and geometric sequences. Let's first recall the formula that we will be using and that you must know. Let's put the formula in a table. In the left column, we will be dealing with arithmetic sequence. In the right column, geometric sequences. First, let's start with the definition. It's a recursive definition for both. An arithmetic sequence is a sequence in which, to go from one term to the next, you add a common difference, a constant common difference, an plus d, like that. This definition leads to an explicit formula for an arithmetic sequence. The explicit formula is that an is a1 plus n minus 1 times the common difference. Another formula is that an equals ak plus n minus k times the common difference. The an in function of a1 is the most common. Finally, Sn, which by definition stands for a1 plus a2 plus an. So what is it for an arithmetic sequence? It is n times a1 plus an over 2. For a geometric sequence, to go from one term to the next, you multiply by the common ratio. We call that r. That's a definition. What is the explicit formula? An equals a1 times r to the n minus 1. And you also have the other one in function of ak. An equals ak times r to the power of n minus k. Here again, the an in function of a1 is the more common. Finally, if you add n terms of the sequence, what do you find? You find a1 times 1 minus the common ratio to the power of n divided by 1 minus r. Let's now go over some problems. So I'm going to do the first one. Here is a sequence. If you look at it, you will find out that it's an arithmetic sequence. You add 4 to go from one term to the next. And the question is, how many terms of this sum are less than 1,000? So the first one is less than 1,000, the second one is less than 1,000, the third one is less than 1,000. We want to know how many. So we are wondering which term goes above 1,000. So we need to solve the equation an above 1,000. Okay? Now a1 is 5 and d is 4. So an is a1 plus n minus 1 times d. So it is 5 plus n minus 1 times 4. And that is 5 plus 4n minus 4, which is 1 plus 4n. And we want that to be above 1,000. Okay? So this is a very simple equation to solve. We have that n is above 999 over 4, which is about 249. Therefore, you have, if you go to 250, you're going to be above 1,000, right? 249 point something, right? 249.7. So at 250, you will be above 1,000. Therefore, there are 249 terms below 1,000. Okay, let's look at the second question. What is the least value n for which the sum of the first n terms is above 1,000? Okay, so you have 249 terms below 1,000, but if you start adding them together, you're gonna get to 1,000 before 249, right? I mean, I hope that makes sense. I don't know what the A248 is, but it's pretty close to 1,000, right? It's around 990 something, right? So A248 plus A247, this is going to be above 1,000 for sure, right? So we want to know how many terms do we need to add to pass 1,000. So the inequality that we have to solve now is Sn over 1,000. And Sn is a sum of an arithmetic sequence. So it is n times a1. So a1 is 5. 5 plus an. An is 1 plus 4n. 1 plus 4n over 2. And we want that to be over 1,000. So if you solve that, what do you find? So you have inside that 6, so it's 6n plus 4n squared over 2,000. So it is 4n squared plus 6n minus 2,000 above 0. Let's divide everything by 2. So we have 2n squared plus 3n minus 1,000 above 0. And we need to solve this inequality. I solved this inequality graphically. I took the calculator. I plugged this function into y1, 2x squared plus 3x minus 1,000. And for the window, I took negative 2530. That's the x min, x max. And the y min, y max, I took negative 1200, 500. And if you do that, you're going to see that the graph looks like this. Like this. And if you ask the calculator to give you this value, it's going to give you 21.6. Therefore, if you add over 22 terms, so S of 22 is going to be over 1,000. Okay? And you can check this actually. I've done it on the calculator. If you look at S of 21, that's going to be 945, while S of 22 would be 1,034. Okay? Let's move on to example number 3. So, example number 3, you have a chessboard in front of you. A chessboard has 64 squares. Okay, here we go. And then you separate in half. I'm not going to do everything right here. Here, in 2, in 2, and in 2. Okay, I'll let you do the other separations. So you get 64 squares in it. And this is what you do. You put 1 grain of rice on the first one, and you double your grain of rice. Okay, so 1, 2, 4, and then 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you double 16 on the next one, so on and so forth. So here's a question. Given that the average mass of a grain of rice is 0.028 gram, that's very light, how much do the rice on the chessboard weight? So we want the total weight of the chessboard, okay? So let's first count the grains of rice. So this is an arithmetic sequence. The first term is 1, and the second term is, well, it's 2 times a1, so it is a1 times 2. The third one is, which is 2. The third one is 2 times a2, so it's 2 squared. Fourth one, you multiply a3 by 2, 2 cubed. Therefore, the nth one is going to be 2 to the n minus 1. So, these are the terms of the sequence. If you want to add all the grains, then let's add them. How many terms are you adding? 64. So it is a1, 1 times 1 minus 2 to the power of 64 divided by 1 minus 2, right here. So actually, let's multiply both sides by negative 1, right here. 1 minus 2 is just negative 1, right? So here, let me just simplify that. It's 2 to the 64 minus 1. This is the number of grains of rice that I'm adding. Now, if 1 grain of rice weighs 0.028 grams, how much does it all weigh? So we need to multiply. So the weight of the whole chessboard is S of 64 times 0.028, and that's gonna be in grams. Let's take the calculator and figure it out. So I want to do 2 to the power of 64 minus 1 times the weight of 1 grain of rice, 0.028. And that's going to be in gram. What is that? Whoa, that's a big number. That means times 10 to the 17. That's a very large number. The E17 means times 10 to the 17. Now, this is in grams. Let's divide that by 1,000 to get it in kilograms. So it is 5.16 blah 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 times 10 to the 14. That is still very heavy. Now in the problem they're talking about tons. I'm guessing it's metric tons, and they said that the world production of rice is in 2011-2012 is about 721 million tons. So let's take this number and let's divide it by 1,000 again to find tons. You have 1,000 kilograms in a metric ton. That's a definition of a metric ton. So what is that? That is still pretty big. So let's get rid of the millions out of that, right? So I'm going to divide that now by 10 to the power of, what is a million? It's a power of 9. No, sorry, a million is a power of 6. That's what I meant. So what is that equal to? Okay, it is equal to 516,508 million tons. Okay, I divided tons by millions, so this is million tons. Now, again, what is the world production of rice? In 2011-2012, 721 million tons. And how much do we have here? 516,508 million tons. So if you divide that by 721, this will tell you how many times the world production of rice you're going to have on that chessboard. So how many times is that? 716 times. On the chessboard you have 716 times the world production of rice. That's a lot. Let's continue. Okay, in this problem, what do we have? We have a bouncing ball that is originally dropped from a height of 40 feet. So here's the ground, and here is the ball dropped from a height of 40 feet. And it bounces. So here's the first bounce right here, and then it bounces again, second bounce, third bounce, fourth bounce, so on and so forth. Every time it bounces, it loses 25% of its height, right? So if let's call the first one right here, let's call that A naught, okay? A naught. So A naught is 40 feet. What is the first? This is A1. A1 is the height after the first bounce. So after the first bounce, the height is 25% of A naught. So it is 40 times 0.25. Okay? After the second bounce, it's 25% of A1. So it is 40 times 0.25 squared. So you see right here, because I started at A naught, my index and my powers are the same. It's all right. Why not? We can do that if we want to. So on and so forth. At the nth bounce, the height will be 40 times 0.25 to the power of n. Okay? So what distance has the ball traveled after the fifth bounce? So you will understand why I started at A naught here. So we want to measure what? We want to measure the distance traveled by the ball. So here is 40 feet, and then it's going to travel A1 and A1 twice A1, and then A2 and A2 twice A2, A3 and A3 twice A3. Okay, so this is a distance traveled after the first bounce. So after the first bounce, it would be A0 plus 2A1, right? This is after the first bounce. And then you add another bounce. So plus 2A2, another bounce, plus 2A3, and then you want to figure out until the fifth bounce, so plus 2a4 plus 2a5. That's a distance covered after the fifth bounce. Okay, so what is that? This is a0 plus 2 times, and then a1 plus a2 plus a3 plus a4, that's a 5 right here. So it is times s5 after the fifth bounce. Okay, so a0 is 40 plus 2 times a1. So a1 is 40 times 0.25 right here, times 1 minus r, so 0.25. And here we have to be careful. a1 plus, okay, so that's power 5 right here. Okay, it's s5, so power 5, divided by 1 minus 0.25. Okay, so what is that? If you take your calculator to compute this number, you would find about 66.6, and it is feet. So after the fifth bounce, the ball has traveled about 66.6 feet. Okay, next question. How many bounds? So now my unknown is n. How many bounds will it take for the ball to cover a distance of 100 feet? So what's going on here? This is when I stop at 5 bounces. Now what I want is a0 plus 2 times, and here I don't know how many bounces, but I know this distance right here, this distance has to be over 100 feet. So how do I solve that? Well, that's pretty okay. Sn is a1, so 40 times 0.25 right here, that's a1, times 1 minus 0.25 to the n over 1 minus 0.25, well, that's 0.75, okay? 0.75. So we multiply all of that by 2. That's Sn right here. You multiply this by 2. You add a0, so you add 40, and you want to be over 100. We need to solve that, okay? Now, 0.25 divided by 0.75, that's just 1/3, okay? So we have, let me move the 40 on the other side. So 100 minus 40 is 60. 60 divided by 2, 30. So we have 40 times 0.25 divided by 0.75, 1/3, times 1 minus 0.25 to the n is above, okay, what did I say here? I said 100 minus 40 is 60 divided by 2, 30 is above 30. Okay, all right, so that's pretty okay. Multiply by 3, divide by 40. So you have 1 minus 0.25 to the n is above 3 times 30, 90 over 40. Simplified by 10. Here we go. So now we're back on very familiar territory. How do we solve this inequality? By using log. So first off, we subtract 1. We have negative 0.25 to the n above 9/4 minus 1 is 5/4. And so we have, I need to get rid of this negative sign right here. So when we multiply by negative 1, we find that 0.25 to the n is smaller than negative 5/4. And at this point, of course, we're like, what? That is not possible. An exponential can never be smaller than a negative number. So what does it mean? It means never. Okay? Never. The ball will never cover 100 feet. Why? What's going on here? Why will it never cover 100 feet? Okay? So I think that's the last question in this problem. Let's see the last question. If the ball bounces forever, what distance would it cover? That's what we need to understand here, why it never will reach 100 feet. Okay, so the distance that the ball covers is a0 plus twice Sn, alright? So it is a0 40 plus 2 times Sn is a1, so it is 40 times 0.25, right here, times 1 minus 0.25 to the n over 1 minus 0.25. This is a distance it has covered after n bouncing, okay, n rebound. All right, so this is 0.75. 0.25 divided by 0.75 is 1/3. So this is equal to 40 plus 2 times 40 times, so here we said 1/3, right? And then, of course, we have this times 1 minus 0.25 to the n. Now, what does it mean that it bounces forever? It means that n is going to approach infinity, right? Now, if n approaches infinity, what's going on here? This is an exponential and the base is smaller than 1, right? You remember that, I hope. So this is going to be 0. Therefore, the total distance should be 40 plus 2 times 40 divided by 3. So it's 40 plus 2/3 of 40. And this is about 66, actually it's exactly 66.66666 feet. This is the maximum distance you can cover. It will stop bouncing before that, actually. This is what's going to happen, right? It's just going to stop bouncing. It cannot bounce forever. And the distance you will have covered when it stops bouncing is about 66.6 feet. Okay? Let's do one more problem. So in this problem, you have a rotating flywheel that is coming to rest. And it's rotating 300 revolutions the first minute. Okay, I'm pretty sure it's going to be a geometric sequence here. So let me write A1 equals 300. In each subsequent minute, it rotates 2/3 as many times as the preceding minute. So in the second minute, it's going to rotate 300 times 2/3. In the third minute, it's going to rotate A2 times 2/3. So 300 times 2/3 squared, right? And so at the nth minute, it will rotate 300 times 2/3 to the n minus 1. Okay, so we have a geometric sequence right here. How many revolutions will the wheel make before coming to rest? So we need to understand what's going on here. How are we going to do that? How many revolutions will it make before coming to rest? So how many revolutions is telling me, hey, I got a compute and a send right here, right? How many revolutions? I'm going to add revolution. This is the number of revolutions during the first minute, the second minute, the third minute. So I need to add revolution. What does it mean that it will come to rest? This is what I need to understand. What does it mean that it will come to rest? So the way I understand it is that at one point, the number of revolution is going to be smaller than 1, okay? And we could say, let's call that the definition of rest. You make less than 1 revolution, therefore it's not going to count. So when does that happen, okay? When does that happen? What is n? Remember, n is like the minutes, right, basically. When does it happen that an is smaller than 1? I don't know. Let's see. Let's fetch it. So 300 times 2/3 to the n minus 1 smaller than 1. We know how to solve that. So that means that 2/3 to the n minus 1 smaller than 1 over 300, which means that, okay, should I take the ln here? Sure, why not? Which means that n minus 1 times ln of 2/3 smaller than ln of 1 over 300. Be careful here, be careful. I am going to divide both sides by this, but this is negative, right? Because 2/3 is smaller than 1. So I need to flip my inequality. N minus 1 is above ln of 1 over 300 divided by ln of 2/3. Here, let's multiply top and bottom by -1. So it's going to be easier to write. So this is ln of 300 divided by ln of 1.5. And then finally, you add 1. So n is above ln of 300 divided by ln of 1.5 plus 1. So what is that with a calculator? It's about 15.06. So you want to be in the 16th minute before you make less than 1 revolution, okay? And so if you want to know the total number of revolution, you just add S16. What is S of 16? So it is A1, so 300, times 1 minus R, so R is 2/3, to the 16, divided by 1 minus R, 1 minus 2/3. So 1 minus 2/3 is 1/3. 300 by 1/3 is 3 times 300. It's 900 times 1 minus 2/3 to the 16. That's going to be pretty close to 0. Okay, so I'm pretty sure my answer is going to be pretty close to 900 revolution. Let's see what it is with the calculator. So the exact answer is 898.2 revolution. So you'll make about 899 revolution before coming to rest. Okay, I'll stop the video here, although there are some other very interesting problems, but this video is a little bit on the long side. I'll stop it here. Please try all of the other problems. Thank you for watching.